In today's lecture, we will start our next discussion on acid rain, followed by ozone layer depletion, and about few protocols. So in this video, we will start with the topic called acid rain. Acid rain is any form of precipitation with high levels of acids. For example, sulfuric acid, that is H2SO4, or nitric acid, that is HNO3. Now, it can occur in the any form of snow, fog, and even dry materials. Not only it will confined in a rainwater, but it can occur in different other ways like snow, fog, and dry material which settle to the earth. Now, most of the acid rain is caused by human activities. When we people are burning the fossil fuels, normally sulfur dioxides, nitrogen oxides are released into the atmosphere. Now, when this sulfur dioxide and nitrogen oxides react in the atmosphere with water or oxygen or any other kind of chemicals, they form those acids like sulfuric acid and nitric acid. And winds actually spread those acidic solution over hundreds of miles and then deposit it. Right. So there are two type of acid deposition process. One is called wet deposition and second one is called dry deposition. What does it mean? Wet deposition, in case of wet deposition, acidic materials falls from the atmosphere to the ground in wet form like rain, snow, fog, etc. And this is called the wet deposition method. So what will happen? The Due to the anthropogenic activities, the sulfur dioxide and NOx are released into the atmosphere, and they actually remain as a gaseous pollutants in the atmosphere, and winds take them away hundreds of miles. And during these pollutants react with the cloud water and precipitates or settle down on the earth's surface. And by this method, they can take the form of like rainwater or snow or fogs. And all these are kind of wet method of deposition. That is why they are called wet deposition process. Other one is called the dry deposition process. And into the dry deposition method, acids are deposited in dry form, such as a dust or gases. They can deposit on the earth's surface. And then this is called the dry deposition method. Now, after it settled down to the earth surface, acid rains enter water system as a runoff and sinks into the ground. So what will happen actually? First, the released nitrogen dioxide or sulfur oxide will react with atmospheric oxygen. For example, for a case of SO2, that is sulfur dioxide, it reacts with first oxygen and then water to form this acid H2SO4. Whereas nitrogen dioxide directly react with atmospheric water to form the nitric acid. And these two acids are released into the atmosphere and it remain in the air or the cloud, and which when deposited directly it is absorbed onto the surface of the earth or the water bodies, or sometimes as a runoff they mix into the water, and by that way the water becomes acidic. Now there is a scale which is called pH scale, which is actually used to measure the acidity of any kind of solution. This is the pH scale. And when pH is 7, it is called neutral. The drinking water or the normal water has a pH 7. Now, if the pH decreases below 7, then the solution is called acidic. And if the pH increases above 7, then this is called the alkaline solution. So, this is a measurement scale. In case of acid rain, the pH is 3 to 6. But in case of normal rainwater, it is 5.4 to 5.6. Now you can imagine in acid rain pH is drastically decreases to 3. So when pH changes from 6 to 3 or below 3, acidity increases by 1000 times. Okay. So in case of acid rains, we can easily conclude that the acidity is very high compared to the normal rainwater. And just because of that, it has adverse effect. What are those effects? Let us look at those effects. Many aquatic species disappear due to the acidification of water bodies, because for the survival of the aquatic species, normal water is very essential. But if the pH drops below the normal water level, then the species will not survive there due to the high acidic nature of the water. Acid rain reduces the production of phytoplankton in the water bodies. It damages the marble houses. It is already, I think all of you know that our Taj Mahal is damaged by this acid rain. It damages the chlorophyll of the leaf. As a result, the rate of photosynthesis will decrease and the plants will die eventually. It also increases the soil acidity, and due to which the plants cannot take water from the soil. So all this kind of adverse effect have um, a lot of create lot of problem for the any kind of living organisms on the earth's surface. So acid rain was a very important issue which is created by the anthropogenic activities or the man-made activities, and it's an effect of air pollution. Another adverse effect of air pollution is ozone layer depletion. On the above the earth's surface, there are a lot of atmospheric layers. Just above the earth's surface, there is a troposphere. After that, there is a stratosphere, mesosphere, thermosphere, and exosphere. 90% of the atmospheric ozone actually lies in the stratosphere. Here, you can see this is the ozone layer. It's just 10 to 50 kilometers in the stratosphere. Now, what is the importance of this layer? Stratospheric ozone layer actually protects us or the human beings or all the living creature on the earth from the harmful UV rays of sun which is coming on the earth's surface. And in this layer, in this stratosphere, ozone is continuously created, and there is an apparent equilibrium between ozone and oxygen. Ozone is created from actually oxygen, small oxygen atom. Ozone, the formula of ozone is O3, that is three oxygen atoms combined to give the ozone molecule. So this combination is going on in the stratosphere, and an apparent equilibrium between ozone and oxygen remain is maintained there. But due to the burning of fossil fuels and all other anthropogenic activities, all other human activities, the release of different kind of pollutants in the atmosphere is increasing. Mainly the chlorofluorocarbons, for example CFCl2, CF2Cl, these are the chemicals which are responsible for the depletion of this ozone layer. So how this is depleting? Now, as I said that solar radiation is coming on the Earth's surface, and this ozone layer actually protecting us from the harmful UV rays. Okay, so due to the increased rate of chlorofluorocarbons and some other volatile carbons which react with this ozone, and eventually the ozone is destroyed in this ozone layer of the stratosphere, and due to which a big hole is created on this layer. Okay, the satellite data actually indicated a damage to the stratospheric ozone layer over the Antarctica on the North Pole, and a hole of the size of a big continent can be observed, or can be easily uh, observed, and due to which all the harmful UV rays are coming on the Earth's surface. It's not protecting us from these UV rays just because of this big hole on this layer. So it's very important issue nowadays that because of our human activities the layer is depleting, and it has an adverse effect on all the living organism, like it may cause skin cancer, eye and lung irritation, it reduces the photosynthesis and affect crop productivity, etc. So if we can stop, or if we can control the uh, release of this kind of chlorofluorocarbons or ozone layer depleting substances or the chemicals, then ozone layer depletion will gradually decrease, and we can survive from the harmful UV rays. Now there are few protocols which are actually taken based on this ozone layer depletion and greenhouse gas emission. In 1987, at Montreal City in Canada, an international agreement is signed, and the main aim of this agreement was to phase out the ozone destroying substances by the year of 2000. So this kind of agreement or treaty is actually taken to control the ozone destroying substances. In 1997, another international convention was signed in Kyoto, which is a city in Japan, and this protocol was taken on the base of greenhouse gas emission, to phase out the gas emission, or to control the greenhouse gas emissions, and it is entered into force on 16 February 2005. The treaty was taken in the 1997, but it started or coming into the force from 16 February 2005. And the first commitment period of these protocols started in 2008 and it continued up to 2012. So that's all for today's lecture, and we will stop here. The next part of this module will be discussed in the next lecture.